a little bit. So I'm saying that the test is only 90% accurate. So we know that if we convert a percent to a decimal, we know that this is equal to 0.90. So here's what I want to do. I want to fill in this table as best I can using my calculator and trying to figure out the numbers. So let's take a look at this. So the first row, I've already determined for you that there's 100 drug users out of 1,000 people. So in the first row, it says a drug user. So if you're a drug user and the test is 90% accurate, then that would mean 90% of the 100 people would test positive. So over here on my calculator, if you're not sure of the math, you do 0.90 times 100. So the drug test would catch 90 of the 100 drug users, but 10 of them would have a negative test, meaning they kind of escaped a little bit. They didn't get caught. All right, so now let's go to the next row. The next row is the non-drug users. So I know then that 90% of the non-drug users, so they're not using drugs, should have a negative test. Again, the test is 90% accurate. So 90 times 900. And that gives me the 810 in this box. So to figure out, oh, by the way I figured out that 10 there was if 90 is a positive test, then 10 have to be negative because I subtracted from 100. For this row, since there's 900 total and 810 tested positive, I would do this. 900 minus 810, and that gives me 90 in this box. So for the total column, I get 180 if I add them up. For this total column, I get 820. Alright, so now let me see. I'm going to rearrange my page a little bit here to answer the questions here on the side. So this one says, what is the probability that if you tested positive, you really were innocent, you were not a drug user? So this is called a false positive. So let's take a look at the numbers I would need to use. I'm looking at all those who tested positive. So that's the first column. And I want to know the probability that it was a non-drug user. So it would be 90 out of 180. So for this first one, it'd be 90/180. So you could do that on your calculator. And you should find, unless you do it in your head, that it's about 50%. So I say round to 3 decimal places. So I would do 0.500. For the bottom one, I'm trying to look at the person tested negative, but they are in fact a drug user. So this is called a false negative, meaning the person was actually guilty, but they got off scot-free. So I want to look at all the negative tests. In this case, there were 820 of them. And for the numerator, I want all the people who were drug users in the negative test. So that's 10 out of 820. So let's see what that gives me. 10 divided by 820. And that gives me a 0.012. And I didn't have to round because the number after the 2 is a 1. So I didn't have to round that one. So I think a false positive is the one that causes most danger because 50% of the people who tested positive really were innocent. So that's kind of like an innocent person being found guilty. But at any rate, that's how we figure out this table. So just pay attention to the numbers that I give you in the problem on the test because the percents may change, the number of people may change, like these rows may be out of 10,000 instead out of 1,000. But just kind of follow through the calculations that I did, and you can rewind the video if that helps. Alright, so this is how we do those two-way tables with conditional probabilities.